Hello again. In this video we're going to do another applying system problem, except it's a little bit different. And in this one, it's actually a type of problem that can, where substitution will actually be the better way to solve it. So let's go ahead and get started. So it says Chris and Mac opened their first savings accounts on the same day. Chris opened his account with $50 and plans to deposit $10 every month. Mac opened his account with $30 and plans to deposit $15 every month. After how many months will their two accounts have the same amount of money, and what will that amount be? So, just like in the previous one, our first thing we have to do is determine what our X and Y will represent. Now, in this situation, we're talking about monthly deposits and a starting amount. And if you notice, in the last one, we were able to use our questions to determine what our variables were. Well, we can do that again here. See, the question says, after how many months will their two accounts have the same amount of money? So we can let X represent the number of amounts, the number of months that has gone by. And what will that amount be? Y could be represent the total amount in their accounts. So how does that work though? Because we have two different people. Well, each person will have their own equation. So watch how I set this up. Let's start with Chris first. We know his total amount will equal his initial deposit, okay, which was right here. Chris opened his account with $50. His deposit plus his monthly payment. Well, his monthly payment is $10 per month, and X is representing the months. Notice I wrote it in slope-intercept form. We can do the same thing for Mac. So for Mac, he opened his account with $30 and he plans on depositing $15 every month. So for him, his is $15 a month plus what he started with was $30. So here is our system that we need to solve. Now as you notice, see how they're both in slope-intercept form? Since they're both equal to y, then these are equal to each other. So I'm actually going to solve this system using substitution. So with substitution, if you recall, I have my two equations. I'm just going to take this one and put it right in here for y. So I'm going to get 10x plus 50 equals 15x plus 30. So I'm going to combine like terms, so I'm going to move the 10 over here, 10x, by using my inverse operations. So I'm going to get 50 equals 5x plus 30, and then I'm going to subtract the 30, again inverse operations. So I get 20 equals 5x, divide by 5, x equals 4. But remember, what does that represent? We set x equal to the number of months. Okay? So again, once we have one of the variables, we solve it, put it back in, and get the other. So it doesn't matter which one we're going to use. I'm just going to go ahead and pick the first equation here, which was Chris's, but it won't matter. So I'm going to put 4 in for x. So I get y equals 10 times 4 plus 50. Y equals 10 times 4 is 40. And 40 plus 50 is 90. So to answer the actual question though, we have to take these answers and put them in the correct perspective. So the first question is, how many months will they have the same amount? Well, that's x. So basically after 4 months. So after 4 months, they will have the same amount. And the second question is, what will that amount be? Well, the amount's going to be $90. So that amount will be $90. And we are done. So in this one, when we set up our linear system, we actually ended up with equations in slope-intercept form, and that's okay. And when those happen, we can easily use substitution to get our answers. Good luck with these.